Yeah, if you can, there we go. All right, so I was just going to focus on sustainability and how sustainability and technologies for sustainability can be used both on Earth and on other planets. And I'm focusing here because one of the biggest tasks, biggest roles of future generations will be to implement more sustainable technologies and make sure that our Earth stays habitable. So I think that the engineers and the scientists that will be developing the technologies to colonize other planets also have a unique position because they have the opportunity to implement research and qualify a bunch of technologies that would also be beneficial for sustainability on Earth. And there's a number of technologies that have promise and have a proven track record of effectiveness that have not been taken up or have not been widespread used because certain supply chain reasons, political reasons. So I think that by using the space community to qualify and implement these technologies, it's an opportunity to have them implemented on Earth as well. So I just went into just 3 example technologies here that show promise and that could be used for both, colonization and for sustainability here on Earth. That for one reason or another have not been fully developed yet. And so I'll just go into each one a little bit, but these are just 3 example technologies. There's a ton of them out there, and I think, like I said, the space community has a unique opportunity to qualify these and make them more widely available for use. So the first is photocatalytic oxidation for air purification. And so this relies primarily on titanium dioxide to clean the air when it is exposed to light. And this material has shown promise in removing volatile organic compounds, bacteria, and some viruses. And it's usually employed either in a coating or in a self-contained unit that can be, that has its own light source. And so this technology, titanium dioxide for photocatalytics, has been researched for decades, but it's still not very widespread on surfaces or in buildings for air purification around the world. There are a few major projects that have been done. There's some in Mexico, there's some in Norway and in Denmark, but it hasn't really been widely adopted yet. And that's primarily because the material is invisible, and it's easy to show that it works in a lab and show its effectiveness in a lab, but it's tough to get politicians and just the general public to adopt it because it's difficult to show its effectiveness in the real world unless you have a very controlled or widespread application of it. So the next one is going to be the molten salt nuclear reactors. And so this was a technology that was developed in the 60s or 50s or 60s, I believe, at Oak Ridge National Lab. And it's a nuclear energy station that does not require a cooling source because the fuel is the cooling source as well. So there has been work done to conceptually scale this to be used in spacecraft and for colonization on other planets. And it has safety benefits versus traditional nuclear reactors. It doesn't need the water source and can be buried underground as well. This wasn't really a widespread adopted yet because supply chains were already set up well for traditional nuclear power back in the 50s when this was developed, and other political reasons. But I think that if this technology was qualified on spacecraft and on future colonization projects, and the safety of it was shown to the general public and the effectiveness was shown, then this could be widely adopted back on Earth as well. The third one is for waste management. There has been a good amount of work done to create cement based off of the ash from incinerated waste. And basically all it uses is the ash, the reclaimed CO2, and the heat from waste incineration, and it makes a sustainable cement that is similar in strength and compressive strength to traditional cement. And this can be made of up to 85% waste ash and can be mixed with soil on foreign planets to create a sustainable and readily available building material. So this will reduce the need to launch material from Earth if you're getting some of your building material just from the ash from your incinerated waste. And again, if this is something that can be shown effective and used in space, it can be brought back here to Earth as well to help with sustainability issues here. So that's really it for me. It's pretty short. I just wanted to dive into these 3 technologies, and you know, there's a whole slew of other ones out there. But again, I just think that it's a really unique position that these researchers and scientists have that will be colonizing other planets to qualify and show the effectiveness of sustainable technologies back on Earth. Thank you.
Fantastic. Thank you, fellas. This was really enlightening, and you guys came and prepared and showed up. I love this perspective. Very cool. All right, let's take a look and see if we have any questions at this time for either one. And if there isn't, which there's not, let's move right into introducing our next guest. And fellas, if you have posted your chapter contact, then folks can send questions directly to you. So thank you again.
I have a question. I may ask.
I'm sorry, go ahead.
Great presentation, by the way. You guys knocked it out of the park. A question about the salt reactors. Are you referring to the sodium reactor? Because my understanding was with the sodium reactor, the whole idea that it's more fail-safe, that it'll be able to shut itself down if to prevent itself from going overly critical and having a meltdown.
Yeah, it's a similar reactor to this. The one in particular that I was looking at uses thorium for fuel. But I'm sure it's a similar design because yes, this one uses the coolant as the same liquid as the fuel. So yes, if you lose fuel, if you lose coolant, you're also losing fuel. So it self-contains.
Great. Are there any other questions that I missed on the online chat that you'd like to ask quickly? All right. Let me